right? Wherein you are asked to find VGS, VGVS, GM R0 and overdrive voltage, right? So I can suffice to say just a minute. Right. So this is your first problem. So in this, this is a simple common source amplifier. Okay, common source amplifier with RG, RD, VDD. Okay, so given data here is VDD is equal to minus VSS equals to 10 volts. Then RG is 4.7 mega ohm. I is 0.5 milliamps. Yeah, this I is same as ID. Yeah. Remember the current flowing this and the current flowing this is 6. So ID is 0.5 milliamps and RD is 15 kilohertz. Right? So I have to find VGS minus VT. Right? VGS minus VT, VGS, VG, VS, GM, and RD. Also, another data I think is missing here, Kn prime. Kn prime W by L. That is 1 milliampere per volt square, and VA is 75 volts. Okay. Now, for this, I can find IDs. Okay, I can write ID formulas mu n COX W by L into VGS minus VT. Okay, so ID I know which is 0.5 milli R into mu n COX. This is Kn prime into W by L is 1 milli into this I will write as VOB. So from this I will get VOB as 1 volt. Okay, VOB as 1 volt. Another data which is missing is VT. VT is 1.5. Okay. So VOB is okay. Overdrive voltage I've got. So VOB is VGS minus VT equal to 1 volt. So from this, VGS is 2.5. Right. VGS is 2.5 volts. So VOB is 1 volt. It is also asked what is VG and what is VS. Right. VG is connected to ground, so VG is 0. VS is VG. VGS is VG minus VS. So on this 2.5 equals to 0 minus VS. So VS is minus 2.5. Right. So found out all the 3, all the 4. This one, this one, this one, and this one. Next, GM and R0. Okay. So GM. The formula for GM is GM is equal to Kn prime W by L into VOB. Right. Kn prime W by L is 1 milli. VOB is 1 volt. So this is 1 milli ampere per volts or 1 millisieverts. Now R naught. R naught is actually given by this mod VA by AD. Okay, mod VA is 75 volts divided by AD, which is 0.5 milliamperes. So this is 150 kilovolts. Okay, so found out all the three values, all the values: VOV, VGS, VG, VS, GM, and R. Right. So straightforward formula, nothing very difficult or anything. Right. But we here, as in, we have not found out what is Rn and all those things. Right. So for that, I'll use the same problem. Okay. Slight extension of the same problem. Okay. Same problem. I'll call it problem 4.1. Okay. So here the additional things which are given are RL will be given. Read out the subscribe. So in this question, what is given is you have R signal plus R signal series V signal. R signal. Yeah, and here you have R. The given data is R signal is 100 kilo ohms, RL plus 15, RL is equal to RD is equal to 15 kilo ohms. V signal is 0.4 volts peak to peak. Okay, this 0.4 volts peak to peak. VDD is equal to minus VSS is equal to 10 volts. I is equal to 0.5 milliamps. Same values as previous. RG is equal to 4.7 ohms. Then VT is equal to 1.5 volts. Kn prime W by L is 1 milliamp per volt square. And VA is 7. The same values as previous. But what is asked? Yeah. That is find. Yeah. Right. First A is A bit is VOV, VGS, then V, GM, then R. V bit is find Rn. Okay, input impedance AV naught. Gain without considering RL, RO, okay, G, overall gain. C bit is if V6 is 0.4 volts peak to peak, then what is V naught? Okay, this is the last bit is very simple. If you find the gain, then you get, if you find GV, then that will give you V naught. Okay. So this is what is asked. So I think A bit is very simple actually, right? For the A bit, we already found the solution to the A bit. We already found VOV to be 1 volt, VGS to be 2.5 volts. 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 2.5 volts and GM to be 1 millisieverts, R naught to be 150 kilowatts. Okay, the thing which is left is VD. Okay, so in this diagram, okay, if I apply KVL with this, okay, if I apply KVL in this direction, okay, then I will get VD as VDD minus IDRD minus VD equal to 0. Right? So VDD is 10 volts minus ID is 0.5 milli, RD is 15 kilo ohms minus VD equal to 0. So from this, VD is 2.5. Remember, VD is 2.5 volts. Vs is minus 2.5. Right. Okay. Vs we got earlier, right? So this is the A part. So the B part is, for solving the B part, you actually have to draw the small signal model, right? So small signal model. Have any queries? Stop me. Okay. So this is plus minus V signal, ground, R signal, then RG, RG, then we have dependent source here, GM into VPS, then R0, R0, this is ground, common source, this is RD, RD, this is R. So this is V. So the second part says that find Rn, find AV0, find Rout, okay, and G, right? So Rn is this distance. This is Rn. This is Rout. Okay, Rn and Rout. Right. So if I look at Rn from this figure, right? Rn is same as Rg. Right. See, Rn is the resistance which is seen into the gate side. Into the gate side, if I see only one resistance, which is Rg. So Rn will be 2.7 kilo. So one problem done. Now, if I look at Rout, okay, Rout is a resistance seen from the drain side, okay, excluding Rn, load resistance. So Rout will be R0 parallel R. Okay, R0 parallel RD. So this is actually 150 kilo parallel RD is 15 kilo. So this will actually turn out to be 13.63 kilos. Okay, this is considering R0. This is considering R0. But if I don't consider R0, okay, then R0 will be simply RD. Okay, which is 15 kilos. This is not considering R0. This is not considering R0. Similarly, I have AV0. AV0. Okay. AV0 is V0 by VA. Okay. Which is minus GM into RD parallel R0. Okay. See, remember, this is AV0. So AV0 means here RL is infinite. If I write AV, then I have to consider R, right? So if I write AV, then it is minus GM into RD parallel R0 parallel R. Okay, this is considering R, but we are finding AV not because that is what is asked, right? So to do this. Right. So if I solve this, GM is minus 1 milli into RD parallel R0 is 13.63. So the gain comes out to be minus 13.63. Right. This is AV naught. Now AV naught again considering R naught. Without if I don't consider R naught, okay, then AV naught is equal to minus GM into RD. So that is straight away 50 minus 50. Okay, 1 milli into 15 kilos. So this is not considering okay. So in the question you might be asked, right? Find the value of AV naught and find the value of AV naught and R out with and without considering R out. So this is how you do it, right? Then we have GV. Okay. GV. Okay, GV here, it's not GV naught, so it's GV. So GV means overall gain including RL. Okay, so this here RL is not infinite. Okay, we have to consider RL. So GV is V naught by V signal, right? V naught by Vi into Rg plus R signal divided by R. Okay, now how did I get this? This is this. This is Vi. Okay, so Vi and V signal, Rg, R signal and Rg are a voltage divider quantity, right? So I can write Vi as V signal divided by R signal plus Rg into Rg. So that is what I've written. Okay, so this is AV into Rg by Rg plus Rg. Right. So AV is, so remember this is AV, not AV naught. So it is minus Vm into RD parallel R naught parallel RL into Rg divided by Rg plus Rc. Right. So if you actually solve, put all the values here. Okay, GM is 1 milli RD and RL is 15 kilo ohms, R naught is 150 kilo ohms, Rg is 4.7 mega ohms, R signal is 100 kilo ohms. Right, so if you put up all those values, this will actually turn out to be minus 6.9. Okay, so it is close to minus 7. Minus 7. Okay. See, generally for gain, the units, there are no units, right? But we can also write it as this V per V, voltage per voltage. Okay. Since it is V naught by V say, it is voltage by voltage. Okay. So this is overall gain. And the C part, in C part, it says that if V signal is 0.4 volts peak to peak, okay, what is V naught? Okay. I think it is fairly simple. We already found GV to be minus 7, right? So that is V naught divided by 0.4 peak to peak. So from this, V naught is minus 2.8 volts. So if I draw the diagram, this is VGS, this is my input, this is 0.4 volts peak to peak, and my VDS will be like this, and this will be 2.8 volts. Right. So this is your common source problem. Okay. So again, I want to make a slight extension to this problem. What I want to do is, see, this problem has no RS. Okay, it has no source resistance. Right. So if I want to do the same problem with the source resistance, all right, then what I do is copy this. This one is called problem 4.5. Okay. So it says that if the input signal, is now is 3 times larger, is 3 times larger. That is V signal is earlier it was 0.4 volts peak to peak. Now it is 1.2 volts peak. Right. Now, what is the value of RS? What is the value of RS to maintain same output level? To maintain same output level. Right. So he's indirectly asking you to solve a problem for having the source resistance Rs. Okay. So this new circuit will actually become like this. Okay. We have this. You have this here. Now you have an RS here. RS followed by this 0.5 milliamps and minus 10 volts. Right now you have this RS. This RS you have. Okay. So what is the value of RS? Well, if you want to maintain the same output level, and V signal is 3 times larger. Right. So if I draw the P model for this, remember, always remember, whenever you have a source resistance, RS, okay, or any other source resistance which is connected in series with the source, right? Instead of using hybrid pi model, always use the T model, right? So from that, if I draw the T model, T model, we have V signal, that's known as V signal, then R signal, then 4.7 milliohms. Then you have 1 by GM. Then you have RS. RS, which is connected to ground. Then on top you have this dependent source. We call this as I. This is connected to ID. And this is connected to R. This current is I input current. And this voltage is VI. This voltage here is VGS. Okay. Right. So what is asked? What is the value of RS? So to find the value of RS here, I think only 10 minutes are left. Let's be able to solve this. So what is asked is GB is equal to V naught by VC. Okay. So V naught, he says same output level. So this has to be 2.8 volts. And V sig is now 1.2 volts. Okay. So I have to find the formula for GB in such a way. In GB, if I find the value from this GB formula, I have to find the value of RS. Right. So that is what is asked. Here I will get some formula. I need to find what is the formula. Right. We already derived this. Okay. To derive again, I'll have to find AV. Okay. What is AV? Okay, so AV is minus GM into RD parallel RL. Okay, there is no R naught here. Right. Divided by 1 plus GM into RS. Right. Remember, upon adding the source resistance RS, what happens is here the it actually acts as a degenerative resistance. Right? It acts as a degenerative resistance. Thereby, it actually reduces your peak. Okay, improves value. Right? So that is what this term is, 1 plus GM into RS. So this is the AV. Now GB here is AV into RG by RG plus RC. Right. This we have derived. Go back to the common source with source resistance. Okay, this derivation is done. Right. So from this GB, which is 2.8 volts peak to peak, divided by 1.2 volts peak to peak, 3 times equal to minus GM into RD parallel RD. Okay, this is the gain divided by 1 plus GM into RS into RG divided by RG plus RC. Okay. So in this, I know all the values. I know the value of GM. GM is 1 milli RD is equal to RL is equal to 15 kilo ohms. Right. Then RG is 4.7 mega ohms. And R signal is 100. This is an extension of the previous problem. Right? So R signal is 100 kilo ohms. So if you substitute all these values, I will find RS to be 2.15. Right. Substitute all these values here, you get RS equal to 2.15 kilo ohms. This you solve it. Any queries still there? Do you have any queries? Please let me know. All right. Then I'll end this meeting. I'll again kindly join back because my time limit is almost up.